So hello, welcome to my first IGCSE paper walkthrough. So today we're going to do the 0606 summer 24 time zone 1 May June. So first of all, on the axis, sketch the graph of y equals -1/5, x plus 2, 2x minus 1, x plus 5. So we have x-intercept of -2, 1/2, and -5. So we first have to note this down. So we have 1/2, 0. We have -2, 0. And we have -5, 0. Then we could find our y-intercept by substituting x equals 0. So y-intercept is -1/5, 2, -1, 5, which is equals to 2. So let's just say the y-intercept is here. So I could guess the shape of the graph to be something like this. Sorry for the drawing. Or something like this. So I guess if you just have the intercepts correct, you have the full credit, and the general shape correct, you have the full credit. So hence solve the inequality of the equation being larger than 0. So we're obviously concerned about this region and also this region. So it's x is less than or equals to -5, or -2 is smaller than or equal to x is smaller than equal to 1/2. Okay, pretty easy. Okay, so we're essentially trying to conduct some polynomial division and to find the remainder, which is r. So we can first write down the polynomial. And then write down 2x minus 5. And then if you conduct the polynomial division, you can have, wait a second, -16x plus 45. So it's -8, -16x plus 40, which yields the remainder of 5. So we write p of x is equals to 2x minus 5 times 3x squared minus 10x minus 8 plus 5, where this r is 5 and then q of x is 3x squared minus 10x minus 8. Good, hence write the expression px minus 5 as a product of linear factors. So px minus 5, we look at the equation above, it's just 2x minus 5, 3x squared minus 10x minus 8. So we factorize it further. You know there's 3x something something, x something something. So using my experience, I could tell it is 3x possibly minus 4 and then plus 2. And this is px minus 5 as a product of linear factors which have the degree of 1. Hence write down the solutions of the equation px equals 5. So px equals 5, it means that p of x minus 5 equals 0. And so if we solve this to be equal to 0, we have x equals 5/2, or x equals -2/3, or x equals 4. Okay, that's relatively simple. So this question tests you about some logarithmic identities. So we can first write 1 is LG10, so we can just write LG10 plus LG of x squared minus 1 minus 2 log x plus 1. We could first simplify the two expressions at the front, minus 2 log x minus 1, and then we can write down log of 2 log of x minus 1 is equals to log of x minus 1 squared. And then finally, we could write it down as log of 10 times x squared minus 1 over x minus 1 all squared. That's good. So solving this equation obviously requires some change of base. So if we choose a base of 5, we could write 4 log base 5 x plus 1 equals 9 times log base 5 of 5 over log base 5 of x plus 1. So log base 5 of 5, this is 1. So we can write 4 log 5 x plus 1 squared equals 9. So log 5 x plus 1 squared is equals to 9 over 4. Taking square roots on both sides will give you log base 5 of x plus 1 is equals to plus or minus 3 over 2. So therefore x plus 1 is equals to 3 over 2, or x plus 1 is equals to 5 to the power of negative 3 over 2. X equals 5 root 5 minus 1, or x equals, well, 1 over 5 root 5 minus 1 equals 5 root 5 over, if we rationalize the denominator, for 1 to 5 minus 1 equals root 5 over 25 minus 1. It only said that a, b, and c are constants, so it does not say that it has to be an integer, so I guess this solution could be correct. The first three terms in ascending powers of x in the expansion of 3 plus px to the power of n are 243 plus 810x plus qx squared. So this is a typical example of using the binomial theorem. Well, first of all, you could easily tell that n is 5 because the first term of the expansion is n0, 3 to the n, px to the 0, which is equals to 243. And so 3 to the n is equals to 243, which gives us n equals 5. Okay, now we can focus on the other terms. So let's just write 3 plus px to the power of 5 equals 243 plus 5, choose 1, 3 to the 5 minus 1 times px. And you know that this is equals to 810x. So 5 times 3 to the 4 times px is equals to 810x. So if we just calculate, we have 405p equals 810, which gives us p equals 2. So now we could just write the third term of the expansion to be 5 choose 2, 3 to the power of 5 minus 2, and then p is 2, right? So it's 2x squared, which is equals to 360 x squared. So therefore q is 360. So just circling the answers out to make it more clear for the marker. There we go. We have 3 answers over here. So find a term independent of y. So we're not gonna just expand the whole thing and to find the constant term. Instead, we're gonna use the technique. You know that the nth term will be in the form of 6 choose r, 2y of 6 minus r, 1 over 3y, negative 1 over 3y squared to the power of r. And then you know that it's independent of r, so you could write something in the sort of y 6 minus r, y negative 2r is equals to some y to the power of 0 because it is a constant. So using some basic index laws, you find r equals 2. So 6c2, 6 choose 2, 2y, 6 minus 2, negative 1 over 3y squared to the power of 2 will give you this is a weird number, 80 over 3. Not sure this is correct, but if they tell us to give it in exact form, it's probably a fraction or a third or whatever. The diagram shows the graph of a cosine bx plus c. So standard question, finding ABC. So you can find A by the amplitude. So this is what we call the equilibrium position. And we can see that's the amplitude here is 5. So A is equals to 5. Second of all, we can find the period by looking at 2 successive parts of this trigonometric function. So let's start off here. So when it completes a cycle, it's around here. So the period is around 480 degrees, which is equals to 3 pi. So if you recall the formula of 2 pi equals b equals to the period, which is 3 pi, you get b equals 2 over 3. Lovely jubbly. And then finally, we can find c by just subbing in x equals 0 and then equates that into 1. So you write 5 cosine of 0 plus c equals 1, which gives you c equals negative 4. So again, I'm going to circle out the values just so it's easier for us to mark it later. The line y equals p is a tangent to the curve y equals 2 sine 6 theta. Find the possible values of p. Okay, so I don't know if this is the most efficient approach, but we could use some calculus. So if you differentiate this equation, you could set it to be equals to 0. So to find the values such that values of theta such that the tangent to the graph will be horizontal, which the line y equals p suggests. So we have dy dx is equals to negative 12 cosine of 6 theta. So if this is equals to 0, so we have negative 12 cosine of 6 theta is equals to 0. So we have 6 theta equals to some k pi over 2, where k is an integer. So for example, we can have pi over 2, 3 pi over 2, whatever. So cosine of that angle will always be 0. So theta is always equals to k pi over 12. So we can write down, so P will be equals to 3 minus 2 sine 6 times k pi over 12 is equals to 3 minus 2 sine k pi over 2. So if k is equals to 1, then we could have 3 minus 2, so we can have p equals 1. But if k equals 3, we have p equals 3 minus 2 negative 1 equals 5. So therefore, p equals 1 or p equals to 5. It's great. It's probably not the most efficient method, but nonetheless, it should be correct. Okay. Some integrals. Okay, so we first of all know that this is natural log of something. So let's just first write down the integral, do it step by step. We can split this up into two integrals and then pull the constant out. So it's, I forgot the dx. So we can have 2 should be trivial. So 1 over 2 ln 2x minus 5 from 2 to 4 minus 3. So is something, some constant multiplied by 3x minus 5 negative 1. So if we do some simple processes, knowing that differentiation is the reverse of integration, you could probably get the constant to be negative 1 over 3. If you differentiate this expression, you would get 1 over 3x minus 5 squared. Okay, that's great. So it's equals to ln of 2 times 4 minus 5 is 3. Minus something's off here. Oh, it's 2x minus 3. If it's 2x minus 5, then it will essentially be undefined because you have ln 0, which is not defined. So we have ln of 5 minus ln of 1 minus 3. So negative 1 over 3 times 7 plus 1 over 3 times 1. Okay, so it's equals to ln 5 plus 1 over 7 minus 1. So it's equals to ln of 5 minus 6 over 7, which is, I suppose, is exact enough. So question 7 talks about some trigonometric identities. So if sine theta equals root y, so we first know that cosecant square theta is equals to 1 plus cotangent square theta. And since cosecant theta is equals to 1 over sine theta, we can say 1 over sine squared theta is equals to 1 plus cotangent squared theta. So 1 over y is equals to 1 plus cotangent squared theta. So by the first equation, by cotangent theta is equals to 3x minus 2. Cotangent squared theta is equals to 3x minus 2 all squared is equals to 9x squared minus 12x plus 4. So 1 over y is equals to 1 plus 9x squared minus 12x plus 4. So y is equals to 1 over all that. So it's 1 over 9x squared minus 12x plus 5. It is pretty tricky, but it is in the formula booklet, so it should be quite manageable. Okay, this is where hell comes from. Okay, so all we have to do is to make sure that we do not miss a solution. So we first of all write sine squared 2 alpha minus power 3 is equals to 1 over 4. And so sine 2 alpha minus pi over 3 is equals to 1 over 2, or sine 2 alpha minus 3 is equals to negative 1 over 2. We just have to make sure that we don't copy anything wrong, or that the solutions should be in the domain. So 2 alpha minus pi over 3 equals to, you can write sine negative 1, or you could write arc sine 1 over 2, or 2 alpha minus pi over 3 equals pi minus arc sine 1 over 2. I hope that does not miss any solutions. So since arc sine 1 over 2 is equals to pi over 6, so we have alpha equals pi over 4, or alpha equals pi minus arc sine 2. So it's 1 over 2 plus 1 over 3. Or alpha equals 5 pi over 12. So similarly, you could write 2 alpha minus pi over 3 equals arc sine negative 1 over 2. This will give you negative pi over 6. So we can have alpha equals 2 pi over 12. You could also have 2 alpha minus pi over 3. You cannot do pi minus arc sine negative 1 over 2, because that would get you a value that is larger than pi over 2. Instead, you could write negative pi minus arc sine negative 1 over 2. So we're essentially going back to the negative direction. So if you recall, it is something related to the unit circle. So this side can be pi, but if you look at it from this way, this could also be negative pi. So by considering this, we could have alpha equals negative pi negative, wait, no, I did something wrong. Negative pi over 4. I hope I did not miss any solutions. It seems like I did miss one, probably, but you know what? I think that's a good enough attempt to this question. Okay, so some index laws and simultaneous equation solving. So let's just label the equations as 1 and 2. So 1 gives us E. By index law, you could add up the indices. So e to the 4x minus y is equals to 1. So 4x minus y equals natural log of 1 is equals to 0. And so we have y equals 4x. So we could substitute y equals 4x into the second equation to give us x squared times 4x is equals to 256. So x cubed is equals to 64, and so x is equals to 4, and y is equals to 16. That's fairly straightforward. So part B is asking us to solve. Okay, I'm so sorry that the recording stopped. So this is pretty straightforward, I would say. So we could just write e to the 1 minus 2x is equals to e to the negative of 2x minus 1. So to just simplify things a bit, so we could substitute this expression 6e to the negative 2x minus 1, and if you divide both sides by this expression, you get 10 of e to the 2x minus 1 squared minus 11e to the 2x minus 1 minus 6 equals 0. And you can make a substitution, or you could just write 5e 2x minus 1 plus 2e 2x minus 1 minus 3 equals 0. So e to the 2x minus 1 is equals to negative 2 over 5. This is rejected because an exponential cannot be smaller or equal to 0. Or e to the 2x minus 1 is equals to 3 over 2. You have 2x minus 1 equals natural log of 3 over 2. So this gives you x equals natural log of 3 over 2 plus 1 over 2. Suppose you only have one solution. Okay, so some kinematics. Okay, so if the velocity is 0, so we have 3 sine 2t equals 0. So 2t equals 0, or 2t equals pi minus 0, which is pi. So t equals 0 is rejected, or t equals pi over 2 seconds. It's rejected because they're asking you about finding the exact value of t in which the velocity is 0 for the first time after p leaves 0. So t must be larger than 0. So for displacement, we're just going to integrate it. So integrate 3 sine 2t dt equals negative 3 over 2 cosine of 2t plus c. So we know that is a fixed point O at t equals 0. So at t equals 0, negative 3 over 2 cosine 2t plus c equals 0, because the displacement is 0. So therefore, it gives you c equals 3 over 2. So displacement, which we call s, is equals to negative 3 over 2 cosine of 2t plus 3 over 2. So find the distance. I have to be careful because distance and displacement are separate quantities. Here we're talking about displacement. We cannot just sub in 0 and pi. We have to instead split it up into segments. So the first segment is when it is traveling to the right. So it is pi over 2, 0. We have to plus that by the absolute value of this expression, because for this segment, the particle will travel to the right, will travel to the left, I'm sorry, and so the displacement will be negative. And if you want the distance, you should take the absolute value of it. So we have to absolute value the whole integral. So this will give you just plug in the values. Equals to 3 over 2 plus. This will give you 3 over 2, which is going to equal 3 meters. That's good. Okay, here we go. So the tangent to the curve, y equals 3x minus 1 raised to the power of a third at this point meets the coordinate axis at some points A and B. The points with coordinates AA lies on the perpendicular bisector of the line AB. We have to find the exact value of A. This is second last question. So obviously, if you see a question asking you about the tangent, you could probably take the derivative of it. So dy dx is equals to 1 over 3 times 3 times 3x minus 1 to negative 2/3 by the chain rule at the point of x equals 3. So at 3, dy dx is equals to 8 to negative 2 over 3 equals to 1 over 4. So this tangent is calculated as, let's see, so at x equals 3, y equals 8 to the power of a third is 2. So therefore, y minus 2 is equals to 1 over 4, x minus 3. So y equals x over 4 plus 5 over 4. Okay, good. The point of coordinate axis AA lies on the perpendicular axis of the point of the line AB. So we now have to find AB. So let's say A, it's when the tangent cuts the y-axis. So you can sub x equals 0 to get 5 over 4. And B can be solved by solving x plus 5 over 4 equals 0. So it's negative 5, 0. So if we're trying to calculate the perpendicular bisector of AB, you should know the slope of it first, by first knowing the slope of AB to be negative 5 over 4 divided by 5, which is negative 1 over 4. And so, did I calculate something wrong? No, I didn't. So therefore, the slope of the perpendicular bisector will be 4. So considering that the midpoint is negative 5 over 2, 5 over 8, we can have y minus 5 over 8 equals 4 times x plus 5 over 2, y equals 4x plus 85 over 8. So if it passes through AA, we could solve A equals 4A plus 85 over 8. So A is equals to negative 85 over 24. this is a bit unconvincing. Probably got some calculations wrong here and there, but I'll take it for now. So this is a standard quotient rule question. So dy dx is equals to 1 over x times x squared minus 2x ln of 3x equals x squared squared. Oh, the reason why you get 1 over 3x is because by the chain rule, you get 3 over 3x, in which they will just simplify out. So it's equals to x minus 2x ln 3x over x to the fourth. And if you factor out x, you get 1 minus 2 ln 3x over x to the third. Okay, hence find this disgusting integral. So we could use the fundamental theorem of calculus, in which you could find if you differentiate some expression, you would get this ln 3x over x cubed. So we can first use part A. You can write if you differentiate ln 3x over x squared is equals to 1 over x cubed minus 2 ln 3x over x cubed. So we're essentially trying to find d dx of something equals to ln 3x over x cubed. So we could first write d dx minus something over x squared, because you're essentially swapping this over and then integrating it. So it should be minus should be d dx minus 2 over x squared, or is it plus? It should give you a negative result, so it should be a plus is equals to negative 2 ln 3x over x cubed. So ln of 3x over x cubed is equals to d dx of this whole chunk divided by negative 2. So therefore, integrating will give you ln 3x plus 2 over negative 2 x squared. So that's the paper done. I think this paper is standard. The values that I got were definitely pretty weird. I don't know if I've gotten all the questions correct, but here we'll see. We'll check the mark scheme. So let me just give me a second. So paper 1, 2024, May, June, time zone 1. So question 1. Question 1, yep, that's correct. Correct shape, that's good. So full marks over here. For question 2, R is 5. That's great. So factorizing, yep. And then the 3 solutions are all correct. For the third question, that's good. And then you should only get 2 solutions, I think. So you get this one, that's correct. And 5 root 5 minus 1, that's also correct. So that's full marks again. Question 4, the binomial theorem. N equals 5, that's correct. P equals 2, that's correct. Oh, I got this one wrong. Why? Q is equals to 1080. So, yeah, I think I wrote something of sorts of. I think I just pressed the calculator wrong, so I'm off by a factor of 3. So that's going to be 1 mark gone, an answer mark. This is correct. Question 5. This is correct. And then B is equals to 3 over 4. The period is 480 degrees. Oh, 480 degrees is not 3 pi, it is. So it's pi, so it's 4 pi over, so it's 4 pi over 3. Yeah. Yeah, I think so. That makes sense. So that's C equals -4. That's correct. A equals 5. That's correct. So that's another mark gone. So sometimes, yeah, you can make careless mistakes, which is okay. Question 6. Ln 5 minus 6 over 7. That's correct. Y equals 1 over 3x minus 2 all squared plus 1. That's okay. That's correct. And then this is the question that I'm most scared of, the 4 solutions. -5 pi over 12. So this is correct. This is correct. And this is correct. -5 pi over 12. Not too sure about that. Why is it not 5 pi over 12? Pi, so you have pi minus pi over 6 plus pi over 3 all divided by 2. Oh, that gives me 7 pi over 12. So this is wrong. I should get 2 alpha minus pi over 3 is equals to, what can I do? Pi minus arc sine negative pi over 6. That does not make sense. That doesn't make sense. Because that would give you a value of more than pi over 2. Negative 2 pi? Perhaps? You do negative 2 pi minus the plus arc sine negative pi over 6. Oh, sorry, arc sine negative 1 over 2. So I'm just very confused over here. How did I get this solution? I should get it from this one, actually. Oh, I could do something like 2 alpha minus pi over 3 equals negative pi minus arc sine of 1 over 2, right? So negative pi minus pi over 6 plus pi over 3 all divided by 2 will give you, yeah, negative 5 pi over 12. Yeah. Well, some careless mistakes over here, so I got 2 I got 3 marks over here, a method mark and 2 answer marks, so that's gonna be -1. It's great. This is okay. This is okay. So pretty strong in solving equations. Power 2. This is okay, and then how did I get this wrong? How is this 6 meters? Oh, it's such a careless mistake, because you get -2 cosine of pi plus 3/2 times cosine of 0, which is 1. You get 3, and then you get 3 here, which equals 6. That's such a careless mistake. Well, luckily it's only -1 mark, but that shouldn't be a mistake that I have to make. Yep, I knew this is something weird. Oh, this is correct. The midpoint is correct. The gradient is not correct, but I wonder why. Oh, because here, okay. So I follow through, luckily. So I also have a method mark over here. So all in all, I have the two answer marks for being deducted. So I get 8 out of 10, so that's another 2 marks gone. It's not a good sight. And then for our last question, that's good. Oh, it's my minus, so it should be +1 over 2x squared. That's a careless mistake. So I get m1. I didn't plus c, so I think I got 2 marks deducted over here. This is not really a good showing. So I get 4 marks deducted, 5 marks deducted, 6 marks deducted, 7 marks deducted, 8 marks deducted. So this is not a good showing by me. So even though I got 90%, which is definitely an A star, some careless mistakes that I've made here are quite inexcusable. But I think that if I had the time to check, I could definitely get this one. I don't know if I'm catching this one, nor I don't know if I'm gonna catch this one, because this does look pretty convincing. Think I'm gonna catch this one. This is a basic arithmetic error. This is also a basic arithmetic error. And then this one is just a bit of a brain fart, if I'm being honest. So yeah, thank you for watching my exam attempts, or walkthrough if you see it this way. So if you like it, then I'll do another walkthrough in a few days on different AMATH papers, or if desired, then I'll go for some IMATH papers. So thank you so much, and bye bye.